Morning, good afternoon, good evening, whichever parts of the world you are watching this show from. And this is your host Rajiv Kulkarni, welcoming you all for the yet another edition of Global Electronics talk show on electronics manufacturing, which happens every Friday and at 8:30 a.m. Central Standard Time, 8 p.m. Indian Standard Time. And this is about the platform talking about the electronics manufacturing challenges, the trend, the technology, and the market outlook that we come across on a day-to-day basis. Electronics manufacturing has been very, very actively, growing across the globe, and as we all know, the gadgets are becoming smaller and smaller, and so the electronic circuits are becoming highly dense and very. I would say the density of the circuit is increasing, which means the power handling capacity is going up. That means narrower the circuits and more power handling capacity, which means you need to have much better equipment, much better challenging technologies, the testing methodology, and so on and so forth. Today's topic, we are talking specifically on the stencils. What is stencil? How many types of stencils are there? And what type of thickness needs to be used? And so on and so forth. There are like hundreds of questions which arises in our mind on a day-to-day basis while we manufacture the electronics. Electronics means basically the printed circuit boards and the components stuffed on the printed circuit boards with this technology called surface mount technology. And in the PCB assembly, the stencils are used widely, and what is that and how it is used and what importance it carries, all those fine details, we are going to have a discussion with the industry expert, Mr. Shaktivel from MST Manufacturing, and he is based out in Chennai, which is in India, southern part of India, and he carries a wealth of experience in the electronics manufacturing for more than 2.5 decades. And let's welcome, ladies and gentlemen, Mr. Shaktivel to Global Electronics show today, the Friday, January 17th. Welcome to the show, Mr. Shaktivel. Good evening to you. How are you, sir?
Hi, Rajiv. Thank you for hosting me here.
It's definitely my pleasure because an industry expert like you and the wealth of knowledge that you carry in the electronics manufacturing, definitely it matters a lot to our audience, to our fellow colleagues in the electronics industry. And that's one of the main reasons that you are here with us today, so we can discuss about a topic that we have chosen about the stencils today. And but before we get into that, let's hear from you little background about yourself, Mr. Shaktivel.
Thank you, Rajiv. It's me, Shaktivel, working as a general manager in MST Manufacturing Technologies, and I carry almost 30 years of almost 28 years of experience in electronic background. Start from PCB designer and PCB manufacturing area as an engineering area, and worked in Bangalore and PCB manufacturing and Malaysia for 2 years, and started stencil activity since from 2007. Now I'm heading this company since last 8 years. We are specialized in making stencil manufacturing as well as jigs and fixtures for MS industry.
So that's a great introduction. Thank you for that, Shaktivel. And so let's come to our main topic of discussion today. What exactly is stencil?
Yeah, stencil, which I would say everybody, most of them who gone to school or colleges, they've been used. Stencil is a unique name, a term, which is the jig, which is producing or creating a print, multiple prints, irrespective of your experiences. Instead of you do you write by manual, and each and everyone's handwriting is totally different. But if you have a stencil, which is a tool, it makes a repetitive impression irrespective of anybody uses. It produces identical, almost closer, similar images on the paper or the image which transfer to the other substrate.
So would you have a presentation that you would like to also present at the same time?
Yeah, I have some.
Slides, maybe?
Yes, I have something to share with you.
So, okay, great. Yeah. As you can see, Mr. Shaktivel works as a general manager operation in Maxim SMT. And yeah. So, yeah, what is stencil? Here it is a display of the slide. Yeah,
It's very tool, with a repetitive impression.
yeah.
It has been commonly used by everyone at least once in their lifetime.
Right.
Yeah, I just show you the basic thing. These are the
Yeah.
stencil to,
Oh, nice.
and this is another stencils to make a square, rectangle, different shape. And obviously this, okay.
Yes. So, what type of different types of stencils are there?
Yeah, when I go for when I talk about SMT stencil, that is SMT stencil totally different.
Okay.
Yeah, SMT stencil is a simple tool. Typically, there is a metal sheet start from 0.04 mm to 0.3 mm thickness used in a SMT stencils. It's all stainless steel sheet or stainless steel metal foil, which creates a aperture, which has aperture by different methods. I don't want to show this. So these are the methods of manufacturing stencils.
Okay.
The ancient method is to make a chemical etching.
Chemical
Use
etching.
chemical etching, and later there's electroforming was there, and recent days there's a laser cutting method. So laser cutting. So both chemical etching, laser cutting are used as a subtractive process, wherein electroforming is additive process, whereby it produces, you make a plating method. You add a metal to produce these stencil thicknesses and apertures opening on the simultaneously. And wherein a chemical etching and a laser cutting is the subtractive method, where you have the stainless steel foil, whereby you'll be removing by different method using chemical or laser, you will be removing the apertures, creating apertures. So this is a electroform stencil manufacturing process, wherein the bare base substrate, which is textured on texture surface, there is a photosensitive material being coated or laminated. Then they do the UV light transfer, that is, they have the image, will be transferred to the machine, through the machine. And then they do expose and start plating the material. They start plating the material, where they grow the material, which is nothing but a stencil. Then later they develop the photosensitive material, then you get the electroform stencil. This is actually electroform method, which is you adding a material.
Okay, interesting.
These are the advantages and the pros and cons, where the process time is higher, initial cost is the high initial cost of film tooling is required. It needs a media to transfer the image aperture informations. But here there is no stress involved, whereby in other cases you need to apply energy to remove the materials.
Nice.
So this is the cutting quality of the material, electroform stencils. You see the whole walls are more smoother than
Yeah.
And the chemical process, almost both are same. Initial 3 steps are same, but here they've been removing the material. They are not building the material. They've been removing the material. The base metal, which is stainless steel, has been coated with the photosensitive. The image has been transferred through UV light. Then photosensitive been developed. Then do etching on both sides, 2 sides. Have the stencils ready. These are very crispy information, but there are many processes being involved in the stencil making. So the disadvantage is this generates a hourglass shape. Both side etching creates a non-uniform flatness in the aperture hole wall. This was possibly very ancient method. Maybe 2 decades ago, there is a stencil which has been produced with that etching method. You see the hourglass method. This is a hourglass. This will affect your phase transfer. But a cheaper version, it's the best one. But it still needs a photo tooling. You don't use. But wherein laser cut stencil uses your Gerber file, your design data as a input to start fabricate the one-to-one aperture opening.
So the laser cut methodology is very efficient when you compare with the chemical etching process?
Far better, maybe I can say even more than 200% better. And nowadays, digital design, which calls for HDI, definitely etching cannot perform.
Correct, yeah. I think because of the tolerance and the very tight tolerance, right?
Tight tolerance, the pitch between each hole. Nowadays, it's supposed to squeezing it out up to 0.3 mm pitch, which will create where you can create only 0.15 as the opening and 0.15 as the gap. So that is a tight tolerance which cannot be attained in a etching method. But wherein laser method, yes, definitely it is possible. And with the post processing, which is called a deburring, will help you to have a better phase release. You need to do the deburring and some chemical treatment or surface treatment to have a whole wall smoothness. That is on subsequent stages.
Okay.
The main idea is to have better positional accuracy precisely to achieve consistency in the printing process.
Very nice, very nice. So um, the stencil thickness, how important it is, in the process?
Okay, the stencil thickness is purely depends on the component footprints, the minimum openings. Each component, what do you say, the connectors openings. Okay, contact openings. Nowadays, the recent which we have been finding it almost a 0.12 or 0.15 is the opening size, which is a BGA.
Okay.
Where the 0.3 or 0.25 is the pitch, where I could get the 0.15 as an opening or 0.12 as an opening. So that way, you cannot definitely cut, uniformly or very universally in standard thicknesses, which is 100 micron or 200 micron. You have to go through aspect ratio calculation and area ratio calculation.
Okay.
So that will define where you can identify the stencil file thickness. And there is another option where you have to do multiple volumes in the single stencils, whereby you do the aspect ratio as area ratio calculation. That is a universal calculation method recent days. That will help you to give localized uh, material thickness variation, which is called
Okay.
step stencils.
Okay. Excellent. And how does it improve, the solder pasting application?
Mm. Again, there is many variants of materials. There is
Yeah.
usually been using a stainless steel 304. Now, the higher version came. It's called a fine grain stainless steel 304 or 301 for addressing finite element openings in the PCBs. So you need to select which model, which aperture opening is being used in the particular design. That will be predicted by the designers, specific the experienced stencil designers.
Okay. Very interesting. So, yeah, you can continue with the presentation that you're showing.
Yeah. So the cover data which I was referring to, it's a
Yes.
sample image where you can open in a notebook. You can see the X and Y coordinate, G codes, and the D code. These are draft code. This is operational codes D01, D02, D03, and end of the file is always M02. This is the file of Gerber.
Ah.
The file of Gerber. All in the, usually I recommend my customer to provide me not only the paste layer, also the track, solder mask, the legend, which is silk layer and fabrication layer.
Mm.
So having all these different layers, we can give a customized stencil opening. We can prepare a customized stencil opening so that we can address this straight to the point. We can predict the process issues which may occur during the printing. So we can address it. Sometimes same component, similar component in a different location of the same board will have a different defects or different performances based on the copper area and then copper track routing and solder mask opening. These are the parameters which have been defined. So many people think that just give the solder paste layer to the stencil manufacturer, you make a
Yeah.
stencil. Oh, this is not the case actually. And recent days, definitely it is not the case. There are many occasions. Very recently, I'm facing is the PCB getting shrink. Customer when
Mm.
there is PCB also have scaling effect,
Correct.
which they don't understand. They think that a PCB is a printer circuit board from the supplier is generating 100% 1:1 output, but not so. There is a scaling variation, but that is scaling variation which is big within the limit as per the IPC standard or customer standards, but still that affect your stencils. So there are many process issues are going on. So they should
Mm.
understand this design activity or a PCB activity. My friend Richard used to tell me PCB is not a printer circuit board. It is a problem comeback. Yeah, always I take that word from him. I used to recommend my workshops or training my customers because everybody thinks that PCB is from the industry where it has 100% okay. But very recently, customer doesn't even they don't believe in. But there are many incidents. We solve the problem by addressing the issues. So need a better understanding of PCBs. In addition to have a better solderability, you should have a better understanding of PCB and PCB surface finishes, PCB raw material, PCB the intermetallic contacts. If you have the better understanding on this area, definitely it will lead a better yield.
Yeah, I think PCB is one thing. What I have experienced is it is not an easy product to manufacture. You know,
Yes,
it is always a challenging product, even though the industry categorizes it as a commodity. But I say that it is not a commodity. It is definitely a very highly technical driven product, and people just generalize it and make it a commodity, as you know, okay, PCB is very easy to manufacture. No, it is not. Every day you have a different challenging factor which arises in the PCB manufacturing. And
correct.
as you rightly mentioned, if you have a very good hold of knowledge on the PCB, I think stencil manufacturing is also pretty much easy to, little bit easy to handle, I would say.
Yes.
Yes, sir. Please continue.
So these are the advantages and disadvantages of a laser cut stencil. This image is very old, but still the process same. This info in the cross-sectional image which you've been seeing. It is just cut, just before post-processing called deburring. All stencils, all laser cut stencil has to undergo deburring process. But is a faster. The recent laser machines with the different driven technologies, now they have a faster manufacturing machines, laser machines. But the thing is, doesn't need any photo tooling, unlike electroform stencil or etching stencil, which needs tooling. The photo tooling is required, but wherein the laser machine directly runs through the Weber data, electronic data from the PCB design.
Okay. Wow. So how it can play a role in improving the quality and reliability?
The stencils,
Yes.
yeah, they should understand. First of all, customer should understand what product they've been running through,
Correct.
what stencil material need to selected for that particular product. There are certain products which needs nickel foil.
Hmm.
There are some material, some product which can still work with the low profile 304. Still, it is called as a 30 stainless steel foil, but there is a different grains which is coming in a cheaper quality. But people in a consumer electronics or low profile goods, they use um, 304 with a higher grain, which is cheaper one. Doesn't require any tension and other thing. But here, for a high HD boards, mainly the mobile phones and laptop, desktop boards, and some recent automotive parts, which is the ECU and audio equipment, mainly the engine control units, definitely needs a fine grain stainless steel. So that will give you better whole wall definition, edge definition. That will reduce the deburring process or the smoothing process, which will help the solder paste to release perfectly, so that customer will not have any printing defects, or it not influenced by material.
Okay.
Okay.
Great, great. Please continue.
So this is one I was telling you, aperture dimension, which is
Yeah.
aspect ratio, and the area ratio and aspect ratio. But this when I take a workshop, I'll take almost half an hour to explain this to my Indian customers with many examples surrounding
Yeah.
that. Simple thumb rule on aspect ratio is the material thickness, the opening sizes must be 105% extra, 150%, 1.5 times extra than the material thickness. Then
Oh, okay.
you will have better transfer efficiency. Nowadays, it is not the case. It is almost reducing because of component geometrics now. And mainly on an area ratio, this is very challenging. Instead of 0.66, this was the standard thumb rule. With this, where aperture size and divided by stencil thickness and the periphery, which results 0.66. That is the general guidelines. It is not
Correct.
fitting into any of the recent components. So in recent days, I've been doing a 0.5 area ratio, but still it is, we have been success because we've been adopting different deburring method. We have been adopted very recently the CVD coated nano coating.
CVD coated nano coating.
Yeah, and we
Wow.
call the ANCVD, which is nothing but advanced nano coating by CVD method, chemical vapor deposition.
Typical
So
deposition.
yeah, in addition to that, my other customers, they have been using different raw material like nickel for mobile phone industry, which is more costlier. The file alone in Indian rupees is 15,000 rupees per file, landed
Wow.
cost. And on top of that, I need to charge them processing costs and extra. So now I changed most of the customer who have been using nickel foils into stainless steel fine grain foil with ANCVD coated, advanced nano coating by CVD method. So now customer feeling the better yield. The yield was whenever they had a yield around 70% or become 95%, 98%. Because of that,
So you find the efficiency of advanced nano CVD coating methodology is better than the other technology.
yes, that is actually surface treatments after the polishing, laser cutting, but that gives a more yield to the customer.
Okay. Okay. But then it is a process needs to be added at customer end or how?
No, it is actually done by us.
So you get it. It is like a process which you offer to the customer after the
Yes,
laser cutting the stencil.
yeah. After the laser cut, we do the deburring, and we have all this equipment, CVD, chemical vapor deposition equipment. It's a bigger in size, almost
Yeah.
very smart
It's
water
like a big chamber, right?
chamber. Yeah, it
Yeah.
is done in a vacuum chamber,
Yeah.
whereby the foils have been loaded in the machine. It coats on the one single side, which is on a PCB side, PCB contact side. So the coating thickness is 100 to 200 nanomicron. It is not a microns,
Yeah.
nanometers,
It is nanomicron. Okay. So
nanometers. Sorry.
it is like a surface treatment process as an option you are providing or it is a must.
We strongly suggest the customer who have been in the mobile phone industry or a high density interconnect, wherever they're using it, for them we specifically say. And people who are who are using in a mass production, high volume production, more than 10,000 per day, then we strongly suggest them to go with this surface finish, wherein it extends the lifetime of the printing and the production time is be reduced. It
Okay.
improves timing, productivity, and indirect cost saving on consumables. Many indirect advantages, but the straight advantages, the better paste release. You don't find any insufficient or high volumes in the printing area. So
Okay.
your line is running 100% free.
Oh, that's very good. Very good, Mr. Shaktivel. We are almost through to the show. Anything else you want to show and add?
Yeah, I have one presentation to show
Please,
on nano
please.
coating thing, so that it's better
Yeah,
for you
please,
to
please do,
have an.
please do. Yeah.
So this is the presentation all about nano coating, which is called the ANCVD. See,
Uh, I
this
don't
will
see
have
that. I don't.
You don't.
Is it still the aspect ratio it is showing?
Okay, I'll change it.
So, ladies and gentlemen, all the presentation which is being shared by MST Manufacturing is the sole proprietary of MST Manufacturing, and it belongs to them. It is Global Electronics does not carry those presentation. It is being presented by MST Manufacturing.
Can you
Oh,
see
very
this logo?
nice. Yes,
Yeah.
yes.
So this is our logo of CVD. Again, advanced nano coated by CVD method. So this CVD, this coating, nano coating will have a blue color effect. Blue.
Oh,
Yeah. So you can easily identify the nano coating availability. See, this is on a different
wow.
color. You see the different color. This is
Yeah,
coat.
I see that. Yeah,
Yeah.
looks very
This is
fancy
not.
too.
Yeah. This is non-coated area. This is all coated area. You see the surface
Yeah,
tension. There's a repulsion on the surface. So
right.
our coating. So this is what is happening. It has been CVD coating has been applied on the PCB contact side also. Inside the upper set also. Inside the upper set also, not only the surface. Because this has been done using a diffusion method, the vapor has been generated, so whereby the vapor has been passing through the whole wall.
Hmm.
So where the coating has been assured. This is the coating thickness is 100 to 200 nanometers, which creates a oleophobic effect. Oleophobic is repulsion, the impact on oil, and hydrophobic is on water.
Wow, nice.
So it helps improve the transfer efficiency and this avoids a bridging.
Yeah,
So this is color coding information. You see the contact angle.
yeah.
Yeah. When we have 110 degree of the contact angle, sorry, it is running in automatic mode.
Yeah, yeah, that's okay.
The more than the contact angle 110 degree, it has the more repulsion. So this is what you see our presentation. My
Right.
operator is standing. So this is a contact angle which we did it on our machine, our product. It measures more than 110.
Wow.
You see here, this is 121 angle. So it has a more repulsion, more surface tension. It never allows the solder paste to stick. It will slip during printing. See, this is test report.
Yeah, very interesting technology though.
Yeah. So you see this test coating thickness measurement, 100 to 200 nanometer, 142. And see the another one, 259, 218, 259, 200. This is done in the last year.
Okay.
This is the evidence here. Before coat, the whole wall gets solder paste accumulated and get dried. Yeah, it is getting accumulated here.
Hmm.
After CVD coating, it has the perfect whole wall smoothness. So it gives a better pitch shape printing after depositing. This is done. This coating has been done using sputtering deposit,
Yeah,
which is used in semiconductor.
correct. Sputtering is a uniform distribution of particles.
Yeah.
Wow.
So never all it just gets through. This is our specification product capabilities here.
How large of the SMT, I mean the stencil size you can go for?
Yeah, sorry.
Okay,
The
I
opening.
see that. I see that stencil foil area 610 by 610. Okay.
Yeah, that is the size. But here I would like to highlight here. This is a very specific aspect issue. I can go up to 1.3, and area
Okay.
ratio I can go up to 0.5 with ANCVD coating.
Okay. That's good to know.
Yeah, this is another stencil presentation. So with this, see, this is a networking board, mobile phone 5G network board.
Oh yeah.
With the 52,000 holes, we could able to achieve the surface, the screen tension 50 newtons. High screen tension with the 4 layers of stencils and vertical stencils with the multiple step biochemical etching. So this is all about our stencil products here.
Very nice.
Maybe I'll share you this PDF for you.
Yes, yes. You can share that separately with me on the WhatsApp. Yeah.
Yeah.
Great, Mr. Shaktivel. We are almost through the time, and you have any particular message you want to give it to our audience?
I should say to all my customers, if they have been stuck, they should not think that the stencil is a product which has the holes. The holes definitely not solve your problem. The holes need a lot of engineering, which we have been investing our time last since from 2007. I've been investing, and we have been giving better product to the customer.
Yeah.
I would like to share our experience to our customers, so whereby I can conduct some workshops. I can present on their line, give them a technical inputs so that they can benefit and they can see the impact of a yield, better yield.
Yeah. Great. You can take off your presentation uh, from the thing. Yeah. So that's very nice of you having with us Mr. Shaktivel. And thank you very much for the presentation you gave on the stencils and also especially on the nanotechnology using the CVD technology of the coating on the stencils as a surface treatment and after the laser cutting technology. I think it definitely will be useful for our audience and the people out there who will watch later on as well, because sometimes people are busy stuck with something or the other, but this particular link will be shared and they can use it to watch it at a later stage. And with that said, Mr. Shaktivel, thank you again, once again, for joining us. And we will join again some other time and talking some other technology with you and sharing that wealth of knowledge with our customer. Thank you, Sandeep, from A&V perspective for streaming and for supporting the audio and visual of this channel. As always, Sandeep is a highly technical inclined person who is based in Bangalore, and any A&V requirement you have for your event and other activities, so definitely you can get in touch with him or you can get in touch with us so we can provide you his contact details. With that said, thank you all the audience out there, and thank you all the electronics fellow colleagues for supporting the channel, and please continue to share the channel with your colleagues. Let them also learn, let them also understand the new technologies or even the exterior technology, because it is being still used in certain manufacturing areas of electronics field. And as we know that electronics manufacturing is not an easy task, it has a lot of challenges of its own. And the idea of global electronics talk show is to bring all these challenges to the audience across globe and share this knowledge. With that said, your host Rajiv Kulkarni will sign off the episode of today, and we wish you good luck. We wish you very happy weekend wherever you are. Please do take your health, and God bless. Thank you very much.
Thank you, Rajiv.
Thank you.